This is a simple block diagram presentation on water pump theory. It will give you the basic concept of how fire engine water pumps work. We will not be showing our actual pumps. That will be for future videos. All our trucks have a water pump. Some are powered by the truck's transmission or power takeoff (PTO), such as our pumper and mini, or by separate gas engines like brush 1, brush 2, or our tender. The water in the tank is not feeding to the pump all the time, only when needed. And water coming from the tank is unpressurized. All trucks have a tank-to-pump valve. This allows the water from the tank to be closed off if you don't need to flow water or are using water from another source. This valve must be opened to allow water from the tank to get to the pump's intake. When you open the tank-to-pump valve, water from the tank flows into the intake of the pump. Once the pump is full of water, the impellers can turn without heating up, creating water pressure, which feeds the hoses through the pump's discharge. Once you have water pressure, you can supply the water to your different discharges. Open the desired discharge to flow the water. As the water flows through the pump and out the hose, the water in the tank will decrease until the tank is empty. When the tank is empty, the water will stop flowing out of the hose. Our pumper has a 750-gallon tank. Our tender has a 1,000-gallon tank. Brush 1 has 500 gallons of water, and brush 2 has a 300-gallon tank. When the pump starts sucking air, the sound of the pump will change, and if you do not stop the pump, it will heat up and seize. Now, where else can you get unpressurized water from? Unpressurized water sources are porta-tanks, ponds, swimming pools, creeks, rivers, and dry hydrants. Now, will this work as shown by opening the drafting valve or suction valve? No, it won't. If there is no water in the pump and in the draft hose, it wouldn't work. That is why our home well pumps are inserted into the bottom of the well where the water is. This way the pump doesn't need to be primed each time it turns on. To get water from an unpressurized source, you will need to place a draft hose, which is a hard, non-collapsible hose, into the water source and connect it to the intake of the pump. To get water into the draft line and into the pump needs to be primed. To provide a proper prime for the pump, a priming device is needed. The primer evacuates, or pumps the air from the pump and hard line draft hose. The pressure inside the hard line and the pump is less than the outside normal air pressure, so the water will go up the hard line into the pump. All our trucks have pump primers. Some are electric and others are manual. Our pumper and mini are electric. Brush 1, brush 2, and the tender have manual primers. The output of the primer pump is opened so the pumped air can escape. After the valve is opened, a motor or manual pump evacuates the air in the pump and draft hose. Again, as the pressure of the air inside the pump and draft line decreases, water is drawn up the draft hose and into the pump. To get technical, this is not suction, just a decrease of the barometric pressure of the draft hose, which allows the water to move up the draft hose and into the pump. Once the water flows out of the primer pump, this shows that the pump and draft hose is full of water and the pump is primed. At this point, the output of the primer pump valve is closed, so no air enters the pump and draft hose, causing a loss of prime. The pump will now pressurize the water in it. Once the pump is primed and the water is pressurized, you can discharge water from the hose. As shown here, we have an empty water tank. We could take the hose that is flowing water and climb onto the top of the truck and fill the tank through the top fill opening. However, since we have the pump flowing water from an unpressurized source, we can use this to fill the tank with an easier method. If we close the discharge valve, we still have the pump pressurized, so let's use that pressurized water. All trucks have a tank fill valve that provides pressurized water out of the water pump, which directly goes into the tank. Open the tank fill valve. Many times this valve is labeled tank fill recirculate. The pressurized water goes through that line into the tank, filling it. When the tank is almost full, reduce the pressure by either reducing the speed of the pump or partially closing the tank fill valve. This will allow the pressure in the tank to reduce so all the air can escape out the tank's overflow so the tank can be completely filled with water. If you don't do this, the tank will not be full. Once the tank is full, close the tank fill valve. You will know when the tank is full as it will overflow out of the top of the tank. If you don't shut the tank fill valve off, the tank will continue to overflow, wasting water. After you fill the tank, you can open the discharge valve and continue to flow water. After arriving on scene, and you start using the water in your tank, before a tender arrives, you may have a partially filled tank when the tender shows up. After you have set up drafting, you can refill your tank while continuing to fight the fire. Keep the discharge valve open and also open the tank fill valve. You might want to not completely open the tank fill valve all the way, as it may decrease your hose pressure. Not opening the tank fill valve all the way will increase the time needed to fill the tank, but will also allow a higher pressure out the discharge. Always keep your tank full. After the tank is full, close the tank fill valve. Keeping the truck's tank full is the responsibility of the engineer or pump operator. If you are not flowing water all the time, such as when you're doing mop-up or you're both doing mop-up and running the pump might overheat. To prevent pump overheating, partially open the tank fill valve or recirc valve to pump a little water back into the pump, and also partially open the tank to pump valve. This allows a small amount of cool water to be drawn from the tank into the pump. This will circulate cold water from the tank, through the pump, and back into the tank. We call this recircing. This will keep the pump cool. You can place your hand on the intake of the pump or on the pump itself to feel if the pump is hot. If hot, increase the amount of water that is recirculated. A warm pump is okay, but not a hot pump. If you're taking water from your water tank and need to cool the pump, recirculate water by partially opening the tank fill valve. The tank to pump valve should be fully open to provide all the water you need to fight the fire. Again, this was a simple block diagram presentation on water pump theory. Be sure to watch the future videos on our pump operations and also attend our hands-on training.